Today we're going to review proportions. Well, what is a proportion? It is two quantities that both change at the same rate. Two quantities that both change at the same rate. Let's look at a couple of examples. If 2 gallons of gasoline cost $6.84, how much would 5 gallons cost? See, we're comparing two quantities. We're comparing gallons and cost. If a car travels 520 miles in 8 hours, what distance could it travel in 1 hour? They're comparing miles and hours. That one is also called a unit rate because it simplifies to just 1. Notice that in each example there are 3 numbers and 2 describing words or 2 adjectives. For example, the first one we compared gallons and cost. Those were our describing words. These are called rates or ratios. So if you'll go ahead and pause the video, you can write your own proportion. See if you can come up with an example of a proportion. My example is, if Jackson can eat 5 hamburgers in 20 minutes, how many can he eat in 8 minutes? It's comparing hamburgers and minutes, and it's got 3 numbers. To solve a proportion, you start by setting up the proportion, which is 2 fractions that are equal to each other. Let's go back to that very first example where we were comparing gallons of gas to the cost of gas. So I've set up my proportion, and the rate is going to be those 2 numbers that we started with. They were in the same little phrase right before the parentheses. $6.84 for the cost for 2 gallons. And they wanted us to predict for 5 gallons. Since 5 is also gallons, it goes on the bottom. See, there's an equal sign in between, which means everything has to be equal or lined up. So gallons goes with gallons and cost will go with cost. There's 2 ways to solve a proportion. First, we can look for a relationship, which means could you just multiply or divide to find the missing number? And sometimes you can, and sometimes you can't. For example, on this one, could you divide 2 by something and get 5? Or could you multiply 2 by something and get 5? Well, if you're really good with your multiplication facts, you might could. What if you simplify? Then would it have a relationship? So we could simplify 2 and $6.84. We could divide both of those numbers by 2, and then you might see that it does have a relationship. But if you don't see the relationship or you're not very good with multiplication facts, then you can simply cross multiply, then divide. So you'd cross multiply both fractions, and it comes out to look like an equation. Then you just solve the equation. So let's solve the example that you just set up. Start by setting up the proportion. In the example I came up with, I was comparing hamburgers to minutes. So there were 5 hamburgers in 20 minutes, and I was trying to predict for 8 minutes. I don't see a relationship. I can't multiply or divide 20 by something to get 8. So I'm going to try to simplify. I can divide 5 and 20 both by 5. And so it simplifies to 1/4. Now look, there's a relationship. What can I do to 4 to make it an 8? I can multiply by 2. So if I do that on top, 1 times 2 would get me 2. So my missing number is 2. He could eat 2 hamburgers in 8 minutes. Now let's discuss finding constant of proportionality. Constant of proportionality can also be called the rate, which is what we just did with the proportions. There's a rate which compares two different things, two describing words, like miles per hour or hamburgers per minute. Let's look at finding constant of proportionality from a table. When washing clothes with brand X laundry detergent, 2 loads require 1.5 cups of laundry detergent. Determine the constant rate of change. So we're going to take the information and put it into the table. 2 loads requires 1.5 cups of detergent. And you can even use your mathematics chart. It has the formula on there. K equals Y over X. K is supposed to stand for constant of proportionality. So we put the Y number on top and the X number on bottom. The Y was 1.5 and X was 2. And then we could divide that out. 1.5 divided by 2, or 1.5 divided by 2, which gets you 0.75. Well, what if we doubled that? If we did 4 loads of laundry instead of just 2, how much laundry detergent would we need? Well, what's 1.5 2 times? 3. And then again, we put the Y number on top and the X number on bottom. And 3/4, well, that's supposed to be one that we memorized, so 3/4 is 0.75. Okay, I'm going to skip the next row and I'm going to go to the one below it. What if we doubled again? So doubling 4 would be 8. So 8 loads of laundry, we'd need to double our detergent. So 3 doubled would make 6. And then put the Y number on top and the X number on bottom. 6/8 simplifies to 3/4, which is still 0.75. Now we kind of have a pattern over here, loads of laundry, 2, 4, and then 8. So we're missing 6. What would 6 loads of laundry be? 4.5 cups of laundry detergent. And if we put that into the table, the Y number goes on top, so 4.5. And the X number goes on bottom, that's 6. And 4.5 divided by 6, you guessed it, is still 0.75. That's why it's called constant of proportionality. The proportionality is the same every time. The rate is the same every time. Now, if they give you all this information in the table already, you can use the change of Y over the change of X. That's where we pick 2 out of the table. And I'm going to pick the 2 that had even numbers. I don't want to have to deal with fractions. And I put the Y's on top. So that was 6 minus 3. And the X that went with 6 is 8. And the X that went with 3 is 4. And then I work that out. 6 minus 3 is 3. And 8 minus 4 is 4. And 3/4 still simplifies to 0.75. What about finding constant of proportionality from a graph? What is the constant of proportionality for this graph? Well, we're going to use change of y and change of x. So in order to do that, I'm going to need to know a couple of the ordered pairs. I'm going to zoom in so we can see the table a little better, the graph a little better. And you can pick any 2 points you want. I'm going to pick this one and this one. The x number goes first, so x is 4, y goes second, and then for this one the x is 8 and the y is 16. So I want to find the change of y and the change of x. So I put my two y numbers on top. The y's were 16 and 8, or you can look at them over here. And the x that went with 16 was 8. And the x that went with 8 was 4. 16 minus 8 is 8. 8 minus 4 is 4. Then I need to simplify that. 8 divided by 4 is 2. So the constant of proportionality for this graph is 2. Or they might want it in words. It would be 2, and we don't say 2 cost per candle, $2 per candle. Just like the y went on top, the y word goes first. The x went on bottom, the x word goes second. Now let's look at finding constant of proportionality from a word problem. Nathway has a job putting letters in envelopes to be mailed. In 1 hour, she puts 42 letters in envelopes. Write an equation to best represent y, the total number of letters Nathway puts in envelopes in X hours if she continues at this rate. Well, her rate is the 1 hour she puts 42 letters in envelopes. And it says in the problem that y is the total of letters. So this is my y goes on top. It says that x is hours, which was 1, that goes on bottom. 42 divided by 1 is 42. So our constant of proportionality is 42. But they ask us to put that into an equation, and we put it in the y equals mx form, where the m is the rate, and we just found out that the rate is 42. So it'll be y equals 42 times x, or they usually write it 42x. Y equals 42x, because if there's not an operation written between them, if it's just a number beside a letter, that means multiply. Let's do a few examples now. Number 1, the graph represents the linear relationship between the number of books Lainey has read and the number of months she has been a member of a book club. Complete the statement to support the rate of change in this relationship. Lainey read blank books in the first blank months she was a member of the book club. Well, if you use the graph and look really closely at the words, the y is representing the books and the x is representing the months. So this first one is 2 months for 3 books. This one over here is 4 months and 6 books. So you could use either one of those points. books is the first word. Books was the Y. That's the second number. So you could put a 3 and then a 2, or you could put 6 and then 4. Number 2. An artist is making a scale model of a statue. On the model, 2 inches represents 1 foot on the actual statue. Which graph best represents this relationship? It's probably best if you make like a little T-chart. X is supposed to represent inches, and Y is supposed to represent the feet. And the scale they give us is 2 inches represents 1 foot. So 4 inches would be 2 feet. They're just dividing by 2. So if we had 8 inches, that would be 4 feet. 12 inches, 6 feet. And if you have a little T-chart, then you can start looking at the graphs and see which one matches the T-chart. For example, if I go over on A, over 4, it goes up to 4. Well, that wasn't in our T-chart, so can't be that one. B, I'm looking for an even one. There's 12. If we go to 12, that would be 2. That's not in our T-chart either. There's C. If I go over 4 and up to 2, that was in the T-chart. Let's check 8. Over 8, over to 4, over 12, up to 6. All of those were in our T-chart. Number 8, if I go over 4, it goes all the way up and it looks like maybe 22. That definitely was not in the T-chart. So the only one that fit our T-chart was C. Number 3, Jeremiah paid $105 for 6 tickets to a hockey game. Each ticket cost the same amount. What was the cost of each ticket in dollars and cents? Well, you could set up a proportion where they're comparing price to tickets and we're trying to figure out how much one ticket would be. Or you could just remember that this is a unit price. They're asking for the price of just one thing, and anytime they're asking for the price of just one thing, you're going to end up dividing, which is what you would have to do if you set up the proportion. So go ahead and work that out. Each ticket is $17.50, and I'm going to go ahead and give it an extra 0 because money gets 2 spaces to the right of the decimal. Number 4, at a school carnival, tickets can be purchased to participate in different activities. The table shows the total cost for different numbers of tickets. What is the constant of proportionality that relates Y, the cost in dollars, to the X, the number of tickets? Well, constant of proportionality, and pretty much any time it talks about X and Y, you might just end up doing the change of Y over the change of X. So we need to pick 2 Y's and 2 X's. So it can be any one that you like from the chart. I'm just going to pick the two small ones because then I have smaller numbers to subtract. So out of the ones I picked, the y's are on the right side, so that's 3 minus 2. The x that goes with 3 is 12, and the x that goes with 2 is 8. Remember, they have to match up together. 3 minus 2 is 1. 12 minus 8 is 4. And 1/4 is the same as decimal 25. So each ticket costs 25 cents. Number 5, a recipe for fruit salad includes 1/3 cup of grapes for 4 servings. How many cups of grapes are needed for 30 servings of this fruit salad? Look at that. There's 3 numbers. We're talking about servings and grapes. Definitely a proportion. So we're comparing grapes and servings. The rate they give us, because it's in the same sentence, is 1/3 cup of grapes to 4 servings. And they want us to predict for 30 servings. Servings has to line up next to each other. Well, there's no relationship. I could not multiply 4 times something and get 30. So I'm going to have to cross multiply. 1/3 times 30. Well, anytime you're multiplying times something with a 1 on the top, you're really just dividing. 1/3 times 30. And cross multiply the other way. Remember, if I don't know what is there, I'm putting a variable, so that's 4 times n. And again, if you are multiplying by a fraction that has a 1 on the top, that's really just division. So 1/3 times 30 is the same as 30 divided by 3, which is 10. Now to solve that, we would need to do the opposite of multiply, which is divide, because I want to get that variable by itself. 10 divided by 4. And you can go off to the side and work that out if you need to. But that's going to equal 2.5, or 2.5, and n on the other side. So how many cups are needed? 2.5 cups. Number 6. The ratio of boys to girls in Mrs. Carr's class is 2 to 3. There are 18 girls in the class. What is the total number of students in Mrs. Carr's class? That one is a little bit tricky, but it is a STAR question. It came from a STAR test. They're going to word them a little bit tricky. Boys to girls. So this is how many boys and this is how many girls. And it wants us to predict for 18 girls. But is it wanting us to predict boys? No, it says total. So I need to have a total. And the total would be 2 plus 3, which means 5. So for our proportion, girls to total, there were 3 girls out of 5. And it wants us to predict for 18. This time there is a relationship, so I don't really have to cross multiply. You could, but we don't have to, because I know that 3 times 6 would get me 18. So if I do the same thing on bottom, 5 times 6 would be 30. 30 students in Mrs. Carr's class. Not really, just feels like that sometimes. Number 7, some doctors recommend that men drink 3 liters of water every day. There are approximately 29.6 milliliters in 1 fluid ounce. How many fluid ounces in 3 liters? What do you notice? I see 3 numbers. 2 of them are talking about, no, look, 3 liters, fluid ounces, milliliters. Oh goodness, those are not the same. So the first thing we need to do is change this 3 liters to milliliters, or change the 29.6 milliliters to liters. Well, there are 1,000 milliliters in 1 liter. So it would take 1,000 milliliters to make 1 liter. That's not enough to make a liter. But the answer wants it in liters, so we need to divide this number by 1,000. 29.6 divided by 1,000. Anytime you divide by a multiple of 10, you count the zeros, and then you move the decimal that many times. So we're going to move the decimal 3 times. 1, 2, 3. And I moved it to the left because usually when you're dividing, that makes the number smaller. We divide to the left, divide and move the decimal to the left. So I'm going to add a 0, and that makes it 0.0296. Liters. Again, that's not my answer. I'm just getting ready to start. Now I need to set up the proportion. Now I have 2 of the same descriptor words. I have ounces and I have liters. And the rate they gave us was that 1 ounce is now 0.0296 liters. And they want to know how many ounces are in 3 liters. So there's the proportion. Again, I don't see a relationship. I can't multiply or divide 0.0296 times something to get 3. So I'm going to need to cross multiply. 1 times 3 is 3. And then some number times n, 0.0296 times n. And to solve that, I'll need to divide by 0.0296. 0.0296. That doesn't look very easy. We could round that and look for something reasonable if it's an answer choice, if they give it to us in multiple choice. However, if that's one of those where you have to give the answer and fill in the blanks like a griddable, you'll need to actually work that out. I'm going to just round. That would round to 0.03, and that'll make it a little bit easier to work out. So 3 divided by 0.03. Move the decimal over. 3 goes into 3 1 time. 3 goes into 0 0 times, 0 times. So it's about 100. If you actually divided with those numbers, you would come out to 101 point, and you get a repeating decimal.